everybody, it's Eugene Liscio here. Welcome to Click 3D. This is the program where we talk about photogrammetry and how you can use something as simple as a digital camera to create really compelling 3D models. A few years ago, I was introduced to a program called 3DF Zephyr, and that was through a student at the University of Toronto. At that time, I had been using some different programs and that sort of thing. And they said, hey, I got this program and, it's free up to a certain amount or whatever, and it does a really good job. And being a longtime photogrammetry user, I decided to have a look at it. And I was really, really impressed with what was being done and the way the software was laid out and everything else. So since then, as many of you know, people have taken my courses and that sort of thing. I have been teaching 3DF Zephyr, and it's been a very successful program. And I think it's a great option for a lot of people. Well, today I have a very special guest. We're going to have the CEO, Yash Singh from 3DFlow here with us today. And he's going to talk to us about the product, about photogrammetry, and about the market in general. So let me bring him in here. Hey, Yash, how you doing?
Hi, thank you so much for having me today. Appreciate it.
Well, thank you for being here. I appreciate it. You're on the sunny West Coast, from what I understand, right?
Right? That's right, down in San Diego. We haven't had too much unfavorable weather, fortunately.
Yeah, lucky for us too. We're actually, being here in Toronto, we've had a very easy winter. I don't know what's going on, but like we are, even today and yesterday, it's just like it feels like we're a month ahead. So hey, I'll take it. COVID situation and everything. I'll take what I can. So hey, listen. So let me ask you. You're the CEO. How did you find yourself into the photogrammetry world? Can you tell me about sort of your progression into this role?
That's a great question, Eugene. Thanks. I've developed over the course of the last 15 years or so several startups. And the very, very first startup was essentially me joining maybe among the first 20 employees. And then the next one was the first 10. And then the third one was the first 3 or 4. And then thereafter, the last 3, I started from the ground up. And those have been very important, both life lessons and also very important lessons on the camaraderie and the entrepreneurship that goes with starting companies and how people bond around a mission. So the last company that I did happened to have been in the medical space. We were developing a diagnostic instrument using a very small optical resonator that we could etch into silicon. It was kind of like trapping light into a ring, and as the light got trapped in there and it circulated millions of times, it would interact with whatever material would then get deposited on top, and that material would slow down essentially the speed of light or change the frequency of the light therein. And that would allow us to detect very minute quantities of DNA molecules as they were binding to each other. We call them oligonucleotides. As I went through that process as an engineer, we built the instrument, we got it out there as early platforms for a few universities in the US. And then we kind of raised the next round of capital. And as it so often happens, as a founder, you go through that process, and then the VCs come in and they say, you did a great job, it was wonderful, but now we need somebody from a healthcare background to really run the company. And you're an engineer, you did great, you understand a lot of what it takes to develop medical products, but you really, really want to take this company down with another CEO. So I said, well, I understand, and you make an amicable separation at that point, because guess what? They're the ones that control the capital that goes into the company, and the company needed the capital. And as a founder, you got to step back and say what's right for the company, and that's an underlying mission and ethos that you really have to take upon yourselves. It hurts sometimes, but you got to realize that you're in here not just for yourself, but for everyone around you.
Right.
And if the company needs the capital to grow, you got to do what's right, both for yourself and the company. So I was going through that process between companies, startups. I was looking at what I wanted to do next, and I had a very specific problem that cropped up as I was developing this particular medical instrument. And it had to do with measuring the physical anatomy in very specific ways. And I wanted to figure out a good way to do that using visible spectrum. So optical 3D modeling was kind of what I wanted to address, or was a solution that I wanted to use to address this problem. And I had no awareness of photogrammetry, to be honest, at that time. And this was roughly about 7 or 8 years ago. So I started reading a lot of technical papers, publications, and so on. And that gives you some insight into what's going on in this field. Is that even something that's possible, right? Can you actually take a series of photographs or video clips and then make a 3D model out of that? I essentially wanted to create a model of a specific object. So I read a whole bunch of papers. There were papers from professors at Stanford University. There were some from the Fraunhofer Institute in Switzerland, Hong Kong University, and then of all places, the University of Verona. And then I made the next step after I'd gone and digested all that. I called on the professors that were and the postdocs that were in each of these universities to understand how far they had gotten. Would they be interested if I was wanting to license the intellectual property that they had either published, be a patent or otherwise, and see if I could enter into a licensing agreement with the university, right? So Stanford, I go to them and they're like, yeah, sure, but it's like, I can give you 5 hours of my time in a month, and it's going to be this much upfront capital for you to license the IP from the university. I said, forget it. I think Stanford's gotten so many spin-offs out of there that they understand the value of their IP probably, but maybe in this instance it wasn't exactly where I was headed, and I needed more participation from the postdocs, the profs. And so Fraunhofer and Hong Kong University were also good candidates, but I really bonded with the professor at the University of Verona. I lived in Italy for a number of years, so I used to speak the language fluently. That may have had something to do with it. But those guys, I mean, there were only 3 people out of the computer vision class in the University of Verona that were beginning to peddle around with the idea of doing a startup. And when I joined them, they literally were already passed. They were already decided to do a spin-off. And I kind of just landed there as they were kind of past the initial stages. But I came in and I wanted to really work with them. And I initially just started to discuss how I could license that intellectual property for a very narrow field of use, which was in this medical space. Well, those guys, they're just amazing. And we worked together for a year and a half. And then at some point, we started talking about how we can be even closer. And then I decided that I would therefore work with them, be a part of them, and have a joint vision on what we were trying to do. And so as part of that, I started dedicating a lot more time into 3DFlow itself. So that's kind of long, short wind of what exactly transpired.
So what year was it that you officially joined?
So this was, I think they may have started maybe a year and a half prior. I joined them sometime in 2000 and I'm going to say 2013, something around that.
Okay.
I have the exact dates there, but it's about roughly eight or 9 years ago.
Okay. Oh, cool. So obviously, I think it's kind of interesting because you didn't have a big background in photogrammetry, but you started at the beginning, and then here you are now, whatever, 7, 8 years, whatever later. So it would be interesting to get your take on what you thought photogrammetry was and what it might do, and then what you think about it today. And I always say that, like for myself, when I started business, when I first started, I thought, this is what I'm going to do. And then you start doing it and it's like, well, that's not going to work, or this is not, now I have to figure out what people want. And then later on, you get to a point where it's like, you start to realize what people need too. And so I don't know if that's any different in the photogrammetry realm or in your area, but I'd be interesting to get your perspective on the whole photogrammetry thing from when you began to now.
Thanks for that question. I think it's interesting you asked that, because I started off looking at photogrammetry as a solution to a particular problem, right? And the early founder, so technically I'm not a founder, so the early founders of 3DFlow were looking um, at leveraging their intricate knowledge of computer vision and developing a tool around photogrammetry, and without any idea of what problem they wanted to solve. They just wanted to get this thing out there. And so the initial um, foundation for a lot of the capital that was generated in order to put food on the table, so to speak, was mostly consulting work. So we did a lot of NRE projects, and some of them were mostly gaming companies that wanted to have more accurate models of facial structures or landscapes and things like that. And so I went in there because I wanted to understand how I could blend both 3D models and fluid mechanics together. I had desired to be able to see if I could construct the outcome of the interaction of two objects, both of which don't have an intrinsic shape, but a shape would emerge due to the interaction of those things together, right? So imagine two balloons, and you squish them together. What exactly is the surface that is the intersection of those two balloons, right? And so it is both an algorithmic exercise, and it was also a 3D modeling exercise. And so that's what my perspective on it was. And the early founders of 3DFlow were more about, well, we've got a bunch of MATLAB code that we can use to create 3D models, but we don't quite know where to take it. And so now if I look on hindsight, it is amazing at the number of applications that people have uncovered for photogrammetry. I mean, I see our tool used everywhere. It's from whether you're a government agency that's using it for remote sensing. So you have customers in Canadian intelligence, they use it. God knows what they use it for, but they use it. We've got NASA, we've got movie studios, we've got gaming studios, and archaeologists, and then architects, and so on. So it's all over the space. And I realized that what we wanted to do, and so early on when I joined, and we were literally in a room, working out of a room in the university, we decided that we would create a generic product. And that product we would use to drive into all these markets, but we wouldn't necessarily go into each vertical per se early on, because we wanted to mature the technology itself. Okay. And so that's where Zephyr kind of came into being.
Can you say anything about the types of people that are using, in your case, your software? Like, do you find that there's a big percentage of people maybe in the gaming area or research, or is there one particular group that stands out to you?
That's a good question, because it has implications on what group of people demand in terms of where they push the envelope of the technology itself. And so if I look at the average consumer who may have secured a drone for their own personal use, they tend to be demanding for creating models of their own personal space, largely. Landscapes and things like that. And so they don't necessarily push the envelope on what the tool needs to be capable of. And then we've got I would say, the government entities that don't really give us much feedback. They just use the tools for whatever applications they have in mind. The most demanding customers, I think, are the movie studios.
Really?
and our gaming studios. I mean, they really have vast repositories of data. And pre-COVID, at least, a lot of them would hold that content within their guarded walls or protected walls, because that's their business model. They have to protect that content that they're creating. And so they would prefer to have large arrays of servers crunching the data as they capture it internally than running these things in the cloud. Because the cloud, it's not even so much about compute anymore, it's about the ingress and egress of data. So it costs money to get data in and out of the cloud, especially the kind of quantities of amounts of data that movie studios work with. But they're the ones that are pushing the envelope for us. So our tool, I believe, is the best in class in the industry because it is the highest quality 3D model that I believe you can create of any of the tools that are out there. And we've gone through numerous benchmarks with numerous companies, tier ones across the board, whether toy companies or movie studios and so on. And so that's where we are kind of focused on. We are much more focused on ensuring that the quality of the output is as close to the actual target that you're trying to image. And that's where the intrinsic nature of the processing becomes very important, because often there are tools that will make that object look nice, but it's not really what it looked like, right? So it's the filter that's kind of covering for lack of accuracy. And so we're all about accuracy, 100%. And so we focus a lot more on that. And because of that, I think some of the success areas we've had, there have been a couple of movies that I can cite because it's now in the public domain. There's a couple of movies released recently. I think there's John Wick 3 and Joker that both employed our tools to merge laser scans and visual spectrum camera scans of the scenery that they had the actors play in. And so when I see those movies, I've seen them both once, it brings a lot of pride to me and the whole team. And it's it makes you feel like you've worked towards something that has meaning, right?
Oh yeah, sure. It's nice when your work can be seen in something artistic, right? So it's quite nice. A work of art, that's for sure. Let me ask you another question. You had mentioned drones. You said, drones, and I think, at least for me, and I don't know if you feel the same way, but once, and I have to give credit to like DJI, but once these drones have really took off, I feel like it gave a big push to photogrammetry again. And did you see sort of an uptick at all when things started to really explode with drones?
Yes, yes and no. Our customer base is a lot more of a mixed bag than I think some of the other companies that are in the photogrammetry space. There are companies that dedicate themselves to provide photogrammetry tools purely for drone customers, and there are a couple of companies that have been in that space before we entered into it. So there's always, therefore, competitive essence there, right? The drone market itself is now getting fragmented, especially with some of the geological or geographical pressures that are occurring, and some customers in the US preferring not to buy, let's say, drones that may have been manufactured elsewhere in the world. The drones that are now made within the US and Canada tend to be at a higher spectrum of requirements, and those have gravitated more towards our tools than the average consumer has, the average DJI drone. But the DJI drone has brought to bear a lot more of awareness amongst people as to what photogrammetry is. Because initially, 7 or 8 years ago, when I first kind of showed this to my kid, I said, listen, this is what I took a bunch of Legos and put them together and made a 3D model of that and say threw that into a game and said, listen, this is what we can do. That wasn't that impressive. But now that you see people toying with this for all kinds of things, I think it's changed the outlook completely.
Oh yeah, for sure.
And now initially people will say to me, hey, this is just photo stitching. This is just like Google Maps. You've stitched a bunch of photos together to give you the perception that you're driving through the street. But that's not a 3D model, right?
No.
It's just like you're wrapped a photograph around a curved space, and that's all it is. So you have all kinds of distortions, radial distortions in those Google Maps. But 3D model it's a difficult challenge from a processing perspective.
Mm-hmm.
We leverage a lot of the compute power that's available on these graphics cards, and to that note, I have to add, NVIDIA has been a fantastic partner. They've supported us all along, and our tool today leverages the entire CUDA instruction set because of that.
Well, I got a fairly new laptop with the new RTX card. So in the last class, people are saying, "Hey, why is your machine always done before us?" It's like a new card. Spent a lot of money on the card, so yeah, that's usually what it is. But that's great. I mean, that's what people want, and it's really interesting because I remember. I mean, I started with photogrammetry in 2006. And I remember taking my first class, and even back then it was a much more manual process, and it took a lot of time. And when I speak to people who are like really old users of photogrammetry, like going back to the 90s even, and they're like, oh yeah, I used to do that, clicking on this point and then clicking on that point, and they spent their whole time clicking on photos and stuff. And so the amount of or automation and the amount of speed now from some of these software programs is really incredible. And so really, really pleased about that. You got maybe somebody wants to come in. You better get it.
Sorry about that. That's reality today.
Yeah, no kidding. Yeah, no big deal. In terms of, you're talking about speed, but in terms of like the types of things that can be implemented into photogrammetry, like for example, everybody's talking about machine learning and artificial intelligence and that sort of thing. Is there a pathway for photogrammetry in the near future in that direction?
That's a really good question. So the entire company is comprised of computer vision experts,
Mm-hmm.
and we often get requests from industrial kairitsus, let's say Japanese term for highly integrated organizations, such as Sony or Fujitsu, or these guys. They make everything. I mean, they make everything from computers all the way to elevators for all. Right? And so a lot of these guys have these large factories, and a lot of the manufacturing processes get automated. And in that process, you have to be able to manipulate objects, recognize them, and also do quality control on them, visual inspection. And so in those kinds of scenarios, machine vision is taking a very strong lead in applying the capture of 3D models, comparing them into silhouettes that are representative of that object from various angles so that you can recognize them,
Mm-hmm.
and then allow robots to be able to manipulate them, right?
Oh, wow, that's fantastic.
So that is, I would say, happening largely already, and it's working on a very limited data set,
Mm-hmm.
because you kind of have that object pretty well characterized or profiled.
Yeah.
But now, if let's say the military comes to you and says, I took this photograph of that fighter jet streaming across the sky. Can you compare that to a library automatically? And you might have taken that photograph from any angle virtually. Can you recognize what that specific airplane is?
Mm-hmm.
That becomes much more of a difficult challenge Still doable because you're looking at a limited data set. You're still looking at airplanes of a particular kind. But now if you've broadened that further, that's where I think the challenge is, and that's where artificial intelligence, neural networks begins to make a much stronger play, where you can allow the algorithms to go through a self-learning process, look at a variety of objects. Can you distinguish a cat from a dog? And let the machine do the work in 3D space as against 2D space.
Yeah, one of the things I'm hoping for is, it's like my dream with photogrammetry is to get rid of all these artifacts you get with glass and reflected surfaces and stuff. And I've always wondered, like, if there would be enough intelligence one day for example, if you're doing a building and you've got windows that, you know, you can say, hey, these are windows and they're flat, you know what I mean? And then you can just kind of, because windows are terrible, you know, subject for photogrammetry. You know, but and to your point, like the other things that are there, like for example, if it, as it's going through the photographs, if it can determine, hey, this is a shiny surface, so maybe I need to apply a different type of algorithm to it versus something else or whatever, that would be super cool. Anything that can improve the, you know, the quality of the data, of the raw data, that would be really helpful.
No, that's true. It's a very good point. It is the Achilles heel of any photogrammetry suite. The reflective surface doesn't have enough data points on it by virtue of its very nature to allow for the tool to track and identify discrete points. And so in limited circumstances or scenarios, we have been able to address that, knowing a little bit more about the nature of the transparent object. So if it happens to be part of a toy of some kind or a industrial product of some kind, then we can recognize that transparency attribute and apply some opaqueness to it, just so that the visual of that still looks somewhat normal. But if you were to take a photogrammetry scan of a building as it is today, and we have no idea whether that reflection is coming from a window or from a mirror or from a highly reflective flat painted surface, it's a lot more challenging.
Okay.
And so I think that's an area where laser or LiDAR helps, because then you can interleave the two things together. Laser scans don't give you any color attributes whatsoever. Photogrammetry does. And so in those scenarios today, at least the state-of-the-art technique is to merge the two things together. And for that, we have a tool within Zephyr that allows you to do that seamlessly with virtually most of the major LiDAR scanners out there. Outside of that, there's some very interesting research at a university level on how to handle transparent objects. And we funded a research program in that area about 2 or 3 years ago for a very specific program with an end customer. And it was reasonably successful there. But we haven't pushed that beyond that at this point. Our priorities going forward in this calendar year are to build a lot more scalability into the product itself. Again, to meet the demands of some of the more studio-like customers that we have, as they put more photorealism in models into their backdrops and into their objects, right? And that's why I think even gaming is such an interesting space, because games are becoming much more photorealistic.
So the gaming and the film industry, did you find that they are, I mean, you mentioned before, like they're using laser scanners, using photogrammetry, they're probably using, you know, maybe 360 cameras and things like that. So do you find that, was that one of the reasons? Did you see a lot more people sort of integrating these things together? And that's one of the reasons why you did it in the software, or?
In that particular instance, I think, yes, we are very customer driven. The company is 100% owned by the employees, and I made it so. I did not raise any capital from outside investors this time around. And so we are all vested in making sure that our customers are 100% satisfied with what they get from us. And because of that, we tend to be driven a lot more by the end customer. I mean, we do a lot of our own road mapping and our own developments that filter into the features that we announce. Zephyr goes through a roughly every 4 months we come out with a semi-major release, and those improvements tend to be driven a lot by customer feedback, and that feedback comes from everywhere. I mean, there are customers in Korea, in the US, and a lot of parts of Europe that are architects or municipalities or consumers that are wanting to have more capability in terms of how they interact with the models and how they blend surfaces and so on and so forth. And we incorporate all of that. And that's the natural evolution of the product, right? And then there are major releases there where we have significant improvements in the platform. And those we tend to do completely through our vision of where we want to take the technology. And those are things like improved edge detection, for example, for surfaces that we are capturing. Scalability of the platform. So how do we allow for this tool to automatically spawn and go out there and leverage all the compute resources that are available? How do we make this tool accessible on the cloud so that people that might have captured images on their cell phones can just upload that without necessarily investing into NVIDIA cards that are apparently continue to be difficult to get a hold of for most people, right? So those are the areas that we kind of driving the nascent technology in, and then a whole bunch of feedback that goes in that kind of provides for incremental improvement. So you'll see, and Zephyr has gone through significant improvements in the last 4 years, especially, I think. I think it's personally, I'm kind of drinking my own Kool-Aid here, but I've tried most of the other tools, and I think that all the tools are good. They all have their strengths, but I honestly believe that for the high-powered user and for the detail-oriented person, our tool is by far the best in the industry.
Well, I can tell you that at least 2 features are in beta because of me. So my constant nagging with your team there. But the great thing is, it is a credit to your team that they do listen. So when I have a problem, it's easy to reach out, and it's nice to get feedback and personal feedback and somebody to look at your project or whatever. So please don't lose that with your team, whatever happens. I think it's nice that people can reach out and actually talk to somebody and get feedback on, whether it's, forums or Discord or whatever platforms there are. It's nice to see that kind of interaction. It's kind of interesting. So in the world that I live in, it's the forensics world. And so most people that work in, collision reconstruction or even in homicides, the drones are the big thing. So there's a lot of people that are using drones with photogrammetry. But one of the things I'm having challenges with is really trying to, or what I've been doing a lot of, is just trying to convince people that, you can use it with just your phone. You can go around and you can take photos. So there's a lot of use by just utilizing the equipment you have right now in order to create 3D models. Do you find that you still have to educate a large group of people still to try and let them know, hey, you can do this already, right? Like, this has been around or whatever. Do you often get surprised the fact that people don't know what photogrammetry is?
Yeah, I think that a lot of that still exists out there. And I don't think, for example, outside of the industry that you're in, forensics specifically, we see a lot of pull coming from there. German police as well, for example, they have a very comprehensive program around this, which we're a part of. And they do drive, forensics is one of the industry drivers for us, at least on some of the areas that we have pushed the technology in. But I think people don't fully appreciate the ease with which you can capture data. given that, to your point, that the cell phones quality of the cameras have improved so dramatically, I don't think it's so much the CMOS sensors that are in these cell phones that are the limiting factor. It's still, let's say, obviously, compared to a DSLR with large CCD sensors in them, is the size of the sensor that matters more than the number of pixels, right? That we all talk about, this is a 10 megapixel camera or 20 megapixel camera, but it's not only the size of the number of pixels, it's also the size of the pixels. That's really, really important, right? And so, but the cell phone cameras gives you a lot of pixels to work with, therefore a lot of discrete points that you can pick up. The challenge is making sure that the consumer is aware of that and buys very cheap accessories that allows you to take stable photographs. I mean, just buy a tripod, mount, and you just mount your cell phone with it, and you're done. You can get great 3D models out of just that, and just make sure lighting is good. You know, go out on a cloudy day. You don't go out when the sun is bright.
I drive my family crazy when I go on vacation because it's like, there he goes. He's taking 100 photos of that damn sculpture. Right? So I'm like, I got to go around and take a photo here. So I'm always driving them nuts. But yeah, it really is amazing what you can do. And especially in areas like, I think, areas which may not be fortunate enough to have a lot of money or equipment, like in archaeology and anthropology, people that are doing a lot of field work where they can't lug around, laser scanners, or they don't have access to it.
It's a game changer.
Yeah.
For people out there in the desert, in the Atacama Desert in Chile, and they're out there taking images of bones that have been preserved in the high altitude deserts there. You can't, there's just no mechanism to haul a laser scanner there, and the power supply and all that. You just take a bunch of photographs, upload that in the night, you're in the tent, you got a battery, and you're processing the data. I mean, it's just amazing. We did one other thing that I'm really proud about in the team. I need to mention this. So when we had the war break out in Iraq, and the Taliban were going about destroying artifacts, we donated our software to something called the Mosul Project. And so you had archaeologists there in Iraq at the time that cared for these artifacts that were prevalent there from the Babylonian era. I mean, you're talking about 1,000, 2,000 years ago, and those artifacts were perfectly preserved till the Taliban came around and just don't want to destroy it all. And so we donated our software to that effort, and the archaeologists used that to at least preserve digital images of that for posterity. I'm glad that we could do that.
I've seen, and I've seen some of that actually. I think there was like those massive sculptures that sort of built into the mountain. There was one, I can't remember what they were called right now, but those I remember were destroyed. And so I remember they were even trying to use historical photos to try and reconstruct some of that. So it's I think for anyone that's out there right now, and just even, I mean, I'm talking about forensics, but in any other area, the fact that even if you don't know how to process it, that's what I tell people. Even if you don't have the software,
just capture the data.
You have the tool that captures the data, right? So that's, my phone's going crazy here. So that's the important part, is that you have the tool already that does the documentation, and I think that's a really important part. So
by the way, one other talking about drones, I think it's useful to mention. California has had its fair share of wildfires. And some of them have been pinned on the local utility companies as they run these power lines across large tracts of land, crisscrossing natural forest reserves or desert areas and so on. A lot of these substations that these utilities have are completely unmanned, and they just sit there subject to the elements. And you don't know where a oxidizing effect of rust on a bolt may result in a line going down just because it shears off due to excess winds and so on. So talking about digital records, digital twins of those kinds of things that allows you to go back. You take a drone. That's where drone applications are just amazing. You go in there over the substation. You don't power down the substation. You take images from the air and you capture all the data you can. When you get the chance, you can power it down. You go by hand and you walk around and take ground level as well. And then you go back every couple of years, and if there's any change, you notice there's oil leaking out of an insulator over there, and these are large, huge, massive structures that they build. You know that something has to be done proactively, and so that would not have been possible. I mean, you had surveyors go out for a month to a substation and camp out there while they do a visual inspection. I mean, that's the cost of that. This is ridiculous. So that's why I think the industry that we're in is going to continue to grow.
Yeah, definitely. And I'm very eager to see like the improvements, as a user, not a large enterprise, but being able to see that you can create really nice 3D models, you know what I mean? Really quality textured models that you can use in so many different areas, I think is fantastic. It's just amazing because, the next step up from photogrammetry is a rather expensive laser scanner, and they have their uses. I'm a laser scanner user myself, and there are there are times when you have to use the laser scanner because photogrammetry is just it's not a really great solution. But I never see them as fighting each other. I always see them as helping each other. You know what I mean? And they really work very, very well together, including things like, for example, we've done some recently. We just published some papers on suspect height analysis, like where we look at CCTV video and how we integrate, frames of video with laser scanner data, and using photogrammetry software, you can do this sort of thing, right? So there's a lot of opportunities that you can do when you fuse multiple technologies together that you couldn't do with just one alone. All right. So, and I think that's a very key or an important point. So I like the fact that in Zephyr, you can bring in laser scans, you can import and export things freely, which is super helpful too. So yeah, that's fantastic. Well, look, we're getting on a little bit in time, and I don't want to take too much of your time, but look, thank you so much for the insight and just for touching base here, whatever. It's great that we can get the CEO of a company every now and then and just and chat. So, but you're the first one. So just want you to know that you're the first one I've had on. So
Eugene, you're so kind. I appreciate it.
Well, I appreciate it too. And like your team has been really wonderful. So, hey, keep up the great work with the software. And yeah, I'm looking forward to seeing what else you guys are going to be doing in the near future.
Thank you so much.
All right. Hey, listen, hang back here, and then I'll just chit chat with you in just a second. Okay.
All right.
Great. Thanks. All right, everybody. Well, that does it. Hey, thanks very much. In the near future, I'm going to be hosting a free photogrammetry week in the first week of April. Look for the announcements online. And if you're interested in 3DF Zephyr, you can go online to their website. Now, one cool thing about 3DF Zephyr is they have a free version, and there's it's right over here, 3DF Zephyr free, and it allows you to work with up to 50 photos, and you can create a 3D model, and you can export the model. Now, you don't have all the features of the software, but it's a great way if you just want to experiment with it, if you want to learn with it. I really like the fact that you can try it before you buy it. All right. Hey, listen, folks, thank you very much for watching, and we'll see you next time on Click 3D. Bye-bye.